Good morning, AP Stats students. Mr. Eicher here to talk about 2018 number 2 about environmental science teachers. Here we're told we have a 95% confidence interval for the proportion, and we're given the interval here, and there are proportions, decimals between 1 and 0. And the first question is, how many students were in the sample? So the formula for a one sample interval for proportion would be p hat, the sample proportion, plus or minus the margin of error. The margin of error is the critical value, z star. We use z star with proportions t star for means, times the square root of the standard error. The standard error can be found on the formula sheet, but it's p hat 1 minus p hat over n. And we're asked to find what is n. So really, once we know p hat, a lot of this formula will be completed. I'll remind you that a confidence interval has two endpoints. Those endpoints are given in the problem. Those endpoints are 584, and then 0.816. P hat was used to construct this interval, and p hat was the midpoint, or is the midpoint of this interval. It was common on this question for students to use p hat of 0.5. Since they didn't know what p hat was, they estimated p hat with a conservative estimate 0.5. But that doesn't apply in this question. We're not asked how many should we sample to attain a certain margin of error. But we're basically told, here's the interval, and we can calculate what p hat is based on the interval. It's that midpoint right there. So let's check out how we can figure out p hat and answer part A. So what I've done here, this interval that's given in the question was based on this formula that we had written on the previous page. So first, I know z star for 95% confidence with proportions. That's 1.96, favorite number, hashtag. And then I took one of these endpoints, you could pick either one, and I plug that in to the formula. So 0.816 came from the plus p hat plus the margin of error. And then we can solve for n. So to find p hat, we can use the, it's basically a midpoint, so you add the two and divide by 2, and that tells you the middle of them, so you get 0.7. Another approach you could use is you could subtract the 2, 84, divided by 2, and I believe that gives you something like 116, something like that, and that would be the margin of error. And then you can take this quantity and set it equal to the margin of error if I subtracted right and divided right. Alright, but either way, we have p hat is 0.7, the midpoint of the interval. So we're going to plug that in. Right there is 0.7 plugged in. And then it's just an issue of solving for n. So we'd subtract the 0.7 from both sides, so we get that. And then the way that I like to approach the issue of having n in the denominator under a square root, I like to divide the numerator and the denominator both into separate square roots, and then move that square root n to the left side of the equation. And then we can divide by the 0.116, that's the margin of error. So we get square root of n equals all that stuff. Square root of n is 7.74, and we get n is equal to 59.953. It was sad that some students left that as their answer, and they were docked points. This was a survey that was actually done, so the answer is 60. Remember, in this context, we always round up to the nearest integer. But really, you would round to the nearest integer, I guess, in this particular type of question, since the survey was already completed. So to get full credit on this, having something like this, or something like this, would be sufficient for your work, and then you would need 60 as your answer. But that was part A. Part B I'd like to dwell on for a while. And this entire question, I think part B is the most important to review because it's been asked most frequently on the AP exam. But this is, given the method used by the teacher to collect responses, explain how bias might have been introduced and how the bias might affect the point estimate of all students in the school. There are 3 things that you have to mention to get essentially correct, full credit on this. So let's take a look at the scoring guidelines. So to get essentially correct, you have to explain why the responses to the survey might differ from the truth about student recycling. So the issue in this question is the environmental science teacher is calling the student into their office and asking this question: do you recycle regularly? So there's some response bias here. The response bias occurs because the survey wasn't anonymous. It occurs because the question was asked by an authority figure, the science teacher. So that's the first thing to look for. And then the response explains how the responses might differ from the truth. For example, students might say yes when they actually don't recycle. The students might lie and say yes. The students don't recycle but lie to the teacher. And then lastly, describes how the effect of the bias on the point estimate and doesn't contradict the bias described. Partially correct if only 2 of the 3, and then incorrect if 0 or 1 of the 3. So let's check out a couple responses. I think I have about 6 responses here. I guess 2 last components to satisfy component 1. Component 1 is explaining why they might differ from the truth. The response must provide a reason that's based on the bias created by the teacher asking the students in person, for example. A response that addresses the wording of the question, volunteer response, or sampling variability does not satisfy component 1. And then to satisfy component 2, how the responses might differ from the truth, the response needs to explicitly contrast what the students say and what they do. Explicitly contrast. Okay, so let's look at some responses. You could pause this video if you'd like to read this response. Let's see if this response hits those 3 things, and part of the reason why I'm doing this is so that you can read your own response and determine how you would score, because ultimately that's the important part, and you understanding and learning the level of communication that's required on the AP exam. So this response says, introduced in terms of response bias. The first sentence doesn't get us anything. The environmental science teacher is likely to support regularly recycling bottles, so students might have been more likely to answer yes to the question, even if it was not their true answer. So let's consider this. So this response is saying, hey, this teacher is more likely to support regularly recycling, so students might have been more likely to respond yes to the question, even if it was not their true answer. So because this response mentions the teacher, that's why the student is giving the answer the way they are. And how does it differ? Well, it differs because now they're more likely to respond yes, even if that was not their true answer. So they've lied. Another way of saying they've lied. They've lied because of the authority figure in the room who supports regular recycling. So that gets both components. Then lastly, this bias might affect the point estimate of all students. by causing the estimate to be too high. So that gets the third component. And then, just in case we weren't sure, due to the pressure to the answer, the students really felt it's likely. So that also addresses the why are they lying. They feel this pressure to answer a certain way. Now, if the student had only said this last part, let's say this was their answer, due to the pressure to the answer to answer a certain way that the students felt, it's likely that the point estimate would be too high. That would get the first component, that would get the second component, how it differs. They get that component, and then it's likely that the point estimate, they get the third component, but they don't get the second component. How is it different from what they actually do? Yeah, they felt pressure to answer a certain way, but maybe they do recycle and they just felt more pressure to say that they do recycle, but maybe they do recycle. So it's unclear just from this last sentence how their answer differs from what they really do. Let's look at another example. So again, this response would get essentially correct. This next one, you can pause the video and read that and think about, do they get those three components? So we have, they feel pressure to answer since they're being surveyed by an environmental science teacher, so they feel that pressure based on the teacher response bias. That would be why they're answering a certain way. Do they get how their answer differs from the truth? They do not. They do get the point estimate might overestimate the true proportion. So they get, of the three components, they get the first and they get the third, but they never explicitly said that they don't recycle, even though they don't recycle. So they might feel pressure to answer yes, a comma, even though they don't really recycle. Don't blah, blah, blah. So this would be scored a partial. Let's look at the next example. You can pause the video and read this and see how you think it would be scored. This would be scored essentially correct. They mention this teacher is an environmental science teacher, may feel that they need to show that they recycle when in reality they might not. So that gets the first two components. And then the point estimate may be higher than it actually is. So that's the third component. That would score an E. Here are two more responses. These are two separate responses. Go ahead and pause the video and read these and see how you think they would each be scored. The first response is very, very close, but it would be scored a partial. What do the students actually say as a response? It says the students don't want the teacher to know that they don't recycle. So we know that they have this reticence to answer, but do they actually lie? Or are they sitting there thinking, well, I don't want them to know that I don't recycle, but maybe they still answer honestly. So they wouldn't get both of the first two components, but they would get the third component, that it's higher than the truth. So that was a tricky one. I'd call that almost like a P+. It's very, very close to an E, but it could be more clear what the students actually say. And then the next response, the teacher personally interviewed the students. As a result, they may have lied and answered yes to look better. As a result, the proportion who say yes may be higher. That's a very good response. That is an E. I think I have two more. Let's check those out. You can pause the video and read these responses and see how you think they were scored. So this response identifies how there might be bias questioned directly, so it's not anonymous, and by the teacher themselves. This would cause the students to feel more obligated to say yes and increase the point estimate. So in this response, we have, there's this issue with response bias being questioned by the teacher. They feel more obligated to say yes, but the question is, do they really recycle or not? I mean, I myself recycle regularly, but if someone asked me, I could feel now more obligated, more pressured to say yes, even though I do recycle. I just feel more obligated to say it. So this is unclear. Is this actually a lie? Is their yes response a lie, or is it just like I felt even more pressure to say yes? So this, and then they get the increase the point estimate part. So this would be scored a partial. Another strong partial, but still a partial. And then the last one, the teacher introduced bias because regularly isn't clearly defined, so this may produce a population proportion that overestimates. This does not get the first two. This is about the wording of the question, and that's not the bias. The question specifically asks with the method that the teacher used, not the question that the teacher used. So that is not going to get either of the first two components. And then the third component is not earned either, because it's not that we're producing a population proportion, but we're producing a sample proportion that estimates the population proportion. So this last response would be scored an I. So I hope that that's a little more clear. I'd encourage you to read your response now and see how you think it would be scored. And if you have a question, you can email me, and I can take a look at it. Let's look at the last part of the question now. Now, I really like the idea of Part C, how you can collect responses from individuals when a question is personal or private. So you have them flip a coin. If it's heads, they have to respond no, regardless of whether they regularly recycle. And then if it's tails, please truthfully respond yes or no. So what this is doing is it's basically giving people an out that if they do respond no, the interviewer won't know. Are they responding no because they flipped heads, or are they responding no because it's really the truth? So it gives people a little more anonymity in their answers. I think it would be cool to do a project with something like this. Idea of flipping a coin and then forcing people to say yes or no. I says, what's the expected number of students in a sample of 300? Well, if you have a sample of 300, and we'd like to know who are required to respond no, well, that's getting heads, so that would be half the time. So the answer would be 150. You'd expect 150 no's in this sample. And then part C, part II, asks this. The results of the sample showed that 213 out of 300 responded no. Based on the results, give a point estimate for the proportion of all students in the high school who would respond yes. So the first part we just said, well, we're expecting 150 to say no. So this is more than we expect. This would be 213 minus 150. That is 63 no's that we weren't expecting. So that means we got 63 no's out of 150. That would be 42%. 42% said no and actually don't recycle. This is about asking yes, so we do the complement, 1 minus 42%. So our estimate for the proportion who actually recycle is 58%. To get an E on this part C, you would have to say, there's a couple of ways. You would have to say 150 in the first part, and then obviously say 58%, the correct answer. Sorry, that would be the only way to get an E. To get a P, there's many other ways. Say 150 in the first part and say 42. You could not say 150 in the first part and then say the correct answer below the 58%. Those are the main two ways of getting a partial. Students did struggle with kind of getting into the thought process here on Part C, but it's a pretty cool question about how to reduce people's inclination to lie about a response because they're embarrassed about their response. Thanks for watching this video. See you next time.